So in this quick video, let's quickly recall what is the derivative of a function of one real variable. In one line, the derivative is that proportionality factor by which we multiply changes in the input in order to get changes in the output. In other words, it's kind of like that amplifying factor, which either magnifies or contracts the amount of change that we induce in the input in order to study changes in the output of a function. So let's take a quick example. Let's say we have one independent variable, x, and we have a function f of x. The way we denote the derivative, a common notation for the derivative, is f prime x. And the way we define it is that change in the value of the function, which is d of f, is f prime x times d of x. Here, d of x is the small change which we induce in the value of the input, and d of f is the associated change in the value of the output. And f prime x is what we call the derivative of the function at the point x. Let's take a quick example by means of two graphs, and just to appreciate the geometrical meaning of the derivative. Let's say we have a function. On the y-axis, we have y, which is f of x, and we have a function which perhaps looks like this. Now, as you can see, this function is very, very slowly changing with how the input is varying. So let's say I am at this point x here, and I change x by a tiny amount from x to x plus dx. The associated change in the value of the output is this tiny vertical line which I'm drawing here. And this is what we denote the ratio of this change in the value of the output to the change induced in the value of the input is what we call the derivative of the function at the point x. And as you can see from this graph, perhaps the derivative here would be a very, very small value. Contrast this with another graph, which might look like this. Now here, as you can see, if I change the input by a tiny amount from x to x plus dx, the associated change in the value of the output is significantly larger than what we saw in the previous graph. So in this case, the derivative would be a larger amount, right? So in one line, as we stated in the beginning, the derivative is kind of like that amplifying factor, which measures in some way the sensitivity of the output to changes in the value of the input. Now, for functions of one variable, the amplifying factor could either increase the value of the function, so it can magnify it, or it can contract it. And at the same time, it could either be positive or negative. So those are the only possibilities when we're talking about functions of one real variable. Now, as we'll see in the next part of the video or in the next sequence of videos, as soon as we try to generalize these ideas to functions of more than one variable, fascinating new things happen. And that's the content of the future of the next part of our videos. So hope to see you soon there. Thanks for watching.